All right, good afternoon, guys, again. This is your review for your Algebra 2 Trig exam for tomorrow, December 1st, 2017. Again, please make sure you study. This test does count towards the third marking period. Okay, so let's look at question 99. So the difference of two squares comes in two forms. We have a squared minus b squared. This is kind of how it's expressed. So when we've done the difference of two squares, we did a plus b and a minus b. But we're doing something a little bit different. We're doing the difference of two cubes, okay? So the first one is difference. How do you know it's difference? Because you're looking at where it says minus. So literally the difference between the two is understanding that difference means subtraction and sum means addition. And based on that, you're gonna have two different formulas to do both, okay? So let's look at A. It says using the sum of two cubes to factor x to the cube, or x third, plus 125. So in this case, because we understand what we're doing, we're going to use the sum. So let's use the sum of that to answer this question. And again, just to be clear what the sum is, and again, you guys are allowed a post-it note for tomorrow. So what you can do is put this on your post-it note tomorrow. So we know that a to the third plus b to the third, in terms of that's the cube, equals a plus b times a squared minus ab plus b squared. Okay, we understand that that is the equation. So again, if you are struggling with this, write down the formula so you know how to answer this question, okay? All right, so now the key to this question is figuring out what's a and what's b. Okay, so the easiest way to figure out what a and what b is kind of cube them both. When we say cube, we mean that. Okay, cube them both. So in this case, the cube root of x to the third power is x. The cube root of 125, and if you have your calculator tomorrow, you can actually do it using your calculator. You can actually pull up your calculator. I'm going to pull up mine. Okay, why is it taking so long? Okay, let's try this again. Okay, it's not coming up. Anyway, there's a button in your calculator you can press. So you can press the math button. When you press the math button, you calculate all these options are going to come up. You're going to click on this option right here. And once that comes up, you can do the cube root of 125. And once you do the cube root of 125, what you're going to realize is the cube of 125 is 5. Okay? So again, okay, perfect. Finally came up. So I'm going to press the math button. I'm going to go down to where it says cube root. As you can see, it says it right there. So that's number 4. I'm going to type in 125, and I'm going to get my answer, which is 5, okay? So I have x plus 5. And now from there, I'm just going to plug everything else in. So I know a was x, so this is going to be x squared. Minus. Now it says AB. AB, B was 5. A was x, so I multiplied them. 5 times x is going to be 5x. Plus, this case will be b squared, so it's going to be 5 squared, and 5 squared is 25. Okay, so that is how I factored out the cube roots. Again, I solved for a. I did the cube of each one. A was x, b was 5, and then I plugged everything in. X squared is x squared. A times b, which is 5 times x, which is 5x. B squared is 5 squared, which is 25. Okay, that is your cube root. Let's go to the next one. So this one asks me for 27 minus y to the third. Because it's a minus sign, I know it's my difference. So I'm going to go back to my difference formula. Just to be clear, my difference formula says a minus b. So it is a minus b. Parentheses a squared plus ab plus b squared. So it's going to be a squared plus ab plus b squared. And again, how do I figure out A and B? It's simple. I'm going to do the cube root of this, and I'm going to do the cube root of this. Okay, so again, let me do the cube root. I'm going to press math. I'm going to go to the cube root. I'm going to put 27, and I'm going to get my answer, which is 3. So I know my A is going to be 3. I know my B, the cube root of y to the third, is simply y. Okay, and then I'm going to plug everything in. So if A is 3, this is going to be 3 squared. And 3 squared gives me 9. Plus, again, A is 3, B is y, plus B squared, if B is y, is this going to be y squared. And this is my answer. Okay? So in these questions, I'm just going to follow the formulas. All you're doing for these questions, following the formula. Okay. Question 100. The y-coordinate of a function becomes the x-coordinate of its inverse. Because of this, we can write an equation for the inverse of a function by substituting x for y and y for x by solving for y. So in order for us to find the inverse, and again, that was one of the questions we talked about in class, we're going to substitute y for x, x for y and y for x, and then solve for y. So what does that mean? Using the strategy to find the equation of the inverse, f of x equals 2x minus 1. So if I'm looking for the inverse for this question, and we kind of said this in class, if this is the equation, what I'm going to do, first I'm going to take f of x, I'm going to turn it into y, because we talked about f of x equals y. In my new equation, in order for me to answer this question, what I'm going to do is, again, replace this with x, and I'm going to replace this with y. And then I'm going to bring the rest of my equation down. Okay? This is the first step. I'm going to replace the x with y and the y with x. And then from there, I'm going to solve for y. So then from there, I'm going to solve for y. Okay? How do I solve for y? Because I want this by itself. My first step, I'm going to get rid of this 1. Since that's a negative 1, I'm going to add 1. I'm going to add 1 to both sides. So now I have x plus 1 equals 2y. Okay? Now, I'm not done yet, because I still got to get y by itself. So now I have to get rid of the 2. I'm going to divide by 2. Whatever I do to one side, I have to do to the other side. So now my new inverse equation is going to be x plus 1 over 2 equals y. That is my inverse equation. Okay, my inverse equation again is this. So again, first step, substitute, instead of y, I'm going to put x. Instead of x, I'm going to put y, and then I'm still solving for y. So my inverse equation would be this. Okay? Okay. For this question, we want to figure out even functions. Okay? So an even function is when it kind of mirrors itself over the y-axis. So if this is the y, if this is my point kind of has to be here. But there's a way for us to do it, solving it algebraically, okay? And the key is this. In order for it to be even, f of x has to equal f of negative x. They have to equal each other. Meaning, if I substitute all the x's for negative x, if these two are the same, then you know what? It is even. If it's not the same, then it's not an even function. Okay, so again, in order for it to be even, f of x has to equal f of negative x. Okay, we're going to do a couple examples and a little later. Okay, factoring completely, we kind of talked about this a little bit since this is not a cube, this is square. It's simple, these are perfect squares. Square root of 4 is 2, square root of x squared is x. The square root of 9 is 3. Square root of y to the second is y. And then we're going to do the same thing, and it's going to be plus. So just be careful. Notice the difference between the squares and the cubes. This is a cube. I'm going to go back to my formula again. because this question said, let's just go back to make sure. Oh, going too far. Okay. Boom. Because it says plus, which one am I using? Let's see. Let's go back. And again, a good idea is to write this down for your test. Because this is plus, I'm using the sum one, okay? Because it's plus, I'm using the sum. So, again, got my thing right here, and then I got my thing right here. A plus B, again, I'm going to cube root this. I'm going to cube root this. For time purposes, we know this is going to be t, and the square root of 27, which we've done already, is going to be 3. Okay, and then I'm going to follow the formula as I see it. So the first one is a plus b, then it's a squared minus ab plus b squared. So a is going to be t squared minus ab, t and 3, which is 3t. And my last one is plus 3 squared is 9. Okay. So again, follow the formulas for each one. Okay. It says the g of x is negative 2x plus 4. Then find an equation for g, the inverse of x, not negative 1. Okay. So this is a two-part question. I have to change this. So again, what are the steps? First step again. First step, I'm going to change the g of x into a y. Second step, I'm going to change the y into x. So now this becomes x. I'm going to change this x into a y. Okay? I want to get y by itself. So my first step is to move the 4. I'm going to minus 4 here. I now have x minus 4 equals negative 2y. Again, I want the y by itself. I'm going to divide by negative 2. I'm going to do the same on this side. I'm going to divide by negative 2. And I have my answer. Okay. Questions? Now, something I could do here, I can simplify. So I'm going to simplify this question. Because I can do negative 4 divided by 2. So I'm going to have x over negative 2 plus 2. Because a negative gives me a positive. So these are your answers. This is how you simplify. Okay? Okay. Moving on. Order pairs, we talked about this, and one of you guys did a great job answering this question. The key to this question, again, they have to be the same number. So you can answer this question in a multitude of ways, but I'm going to do it quickly, and an easy way to do it, and I'll write it big so we can see it, 5x plus 4y equals negative 30, and you have 3x minus 9y equals negative 18. I'm going to change the x's because they're just right in front of me. You can change the y's, it doesn't matter, but I'm going to change the x's. How do I change the x's? Well, I want these two to be the same, so I'm going to multiply them by the opposite. So I'm going to multiply this by 3. I multiply the bottom by 5. Okay. So in this case, you have to change both equations. So I'll do the first one first. 3 times 5 is 15x. 3 times 4 is 12y. 3 times negative 30 is negative 90. Do the second one. Okay. 5 times 3 is 15x. 5 times negative 9 is negative 45y. And 18 times negative 5 is negative 90. Okay. So now, I have two 15s here. In order for me to answer this question, if they're both positive, the only way you eliminate positive is through subtraction. Okay. If one was positive and one was negative, then you would eliminate this through addition. Okay. But in this case, because they're both negative, we will eliminate using subtraction, okay? Yep. So we're going to subtract, okay? 15 minus 15, 0. 12 minus negative 45. I should actually want you to type this in your calculator so you don't get this wrong. So this is 12 minus negative 45. And that gives me 57. So this is going to be 57y. And I'm going to do the same thing up top. 90 minus negative 90. So I'm going to type in 90. It's going to be negative 90 minus negative 90. And I'm going to get 0. Don't look alarmed. It's possible, okay? I'm going to divide each side by 57, and I'm going to discover that y equals 0. Okay? I've only solved for y. Now I'm going to go back and solve for x. You could pick either equation. I will pick one of the original equations. I'll do the 5x plus 4y to make life easy. So again, 5x plus 4y equals, I forgot the number, let me see what number that was again, negative 30. And again, y is 0, so I'm going to replace this y with 0, and then I'm going to solve the equation. Okay. 4 times 0 cancels out because it's 0. I have 5x. And again, because it cancels, I can kind of get rid of it. I have 5x equal to 30, negative 30, excuse me. I divide each side by 5. And I'm going to get x equals negative 6. So now my final answer is going to be negative 6, 0. Algebraically, determine whether or not the function is an even function. You can confirm your graph for results graphing. So, how do we do this algebraically? And again, we talked about this, and I'll move the graph to the side for a second, just so we can see this. In order to confirm this algebraically, and again, just remember that the function has to equal the same function if you make it negative. In this case, it says j, so j of x has to equal j of negative x. So here's what I'm going to do. I'm going to take the function. So j of x equals x to the 4th minus 3x to the 2nd minus 4. I'm going to take that function, and what am I going to do? I'm going to replace all the x's with negative x. So I'm going to replace any x I see. I'm going to put a negative x. So I see an x there, I'm going to put negative x. I see an x here, I'm going to put in parentheses negative x. I see an x there, I'm going to put a negative x. Okay, I'm going to put a negative x. Let's do the math. Seth kind of did this in class today. Negative x to the 4th power, that's negative x 4 times. Don't mind that. So negative x times negative x times negative x times negative x. Okay, let's look at it. A negative and a negative is a positive. A positive and a negative is a negative, and we're going back to a negative and a negative is a positive. So now I know that negative x to the 4th power is positive x to the 4th power. Okay. Let's do this one. So that was that one. So now I have negative 3 times negative x times negative x. Okay? So, actually, because that's an exponent, we should do this first. So negative and a negative gives me a positive x squared, and then I have that times this, which actually gives me a negative 3x squared. And then we have minus 4, because nothing changed with the 4. So if I scroll back up, this is the original equation, x squared, x to the 4th power minus 3x squared minus 4. When I did the inverse, I have x to the 4th power minus 3x squared minus 4. And because they equal each other, so again, because this equals that, it is an even function. So the answer is yes, it's an even function. Okay. So that is how you determine if it's an even function. You can confirm your results graphically by plugging it into the graph. And I'll quickly show you how to do it. X to the 4th power minus 3x minus 3x to the 2nd minus 4. Press graph. Okay, and look what happens. You see the reflection over, okay? So that's how you can confirm a graphic. Okay. Moving on. Sketching. This is important. The graph of the function f of x is shown on the set of axes at right. On the same axis, sketch the graph of g of x if g of x is f x plus 3 minus 1. So this is my graph. I want to know f plus 3 minus 1. So what you're simply going to do, you're going to graph this using these rules. So because it's minus 1, it's on the outside, this graph is actually going to go down. It's going to go down 1. So A is going to go down 1. Okay? Because it says plus 3 and it's in the parentheses, sorry, this is down. Because it's plus 3 is in the parentheses, we talked about this in class, it's actually going to go, not right, it's going to go left 3. Okay? So, I'm going to take my graph. Sorry guys, just to let you know, I'm using my fingers when I trace it, so it's going to look a little funny. I'm going to go down 1, and I'm going to go left. So I'm going to use this point right here. Sorry, let me try that again. A smaller dot so you can kind of see it. I'm going to use this point right here. I'm going to use this point right here. I'm going to use this point. And we'll use this point, okay? We're going to pretend that point's a little bit over, okay? I'm just going to go down 1 and left 3. 1, 2, 3. So that point went from here to here. I'm going to do the same thing. I'm going to go down 1 and left 3. 1, 2, 3. So that point moved there. I'm going to go down 1, left 3. Okay, and I'm going to go down 1, left 3. Guys, this is my new function. Okay? This is my new function, excuse me, and it come out as sharp as it should have. And what I'm going to do, just to make sure we're clear, I'm going to put that this is now g of x. Okay. Questions? Okay. What value of x satisfies this equation? So we want to know when they're going to be equal. You can use the graph for that. You can kind of plug them in. You can kind of see what the differences are between the two. Okay? But we just want to know what value of x will satisfy when they're equal. Okay? C, same axis, you're going to graph the same thing. Okay? So we can kind of skip through that because I don't want to spend too long in the video. We talked about factoring again and again. Remember, because it's difference, use the difference formula. Okay? And remember, just do like this. Cube root to get the numbers for a. So in this case, a will be 4x. In this case, b will be y. Okay? Okay. Write an equation of an even function that's not in the problem set. So you just kind of write an even function. So again, if I make up a function, let's say I make up y equals 2x plus 2. Remember my steps. First step, change the x and y. And then just solve. Then just solve, okay? Then you're going to divide, then you're going to divide. If you're struggling with this question, rewind the video back to that number question. And again, same thing here. And again, f of x equals 3, parentheses x minus 1. Change the y. Okay, and then change the x. Same idea, okay? All right. If the domain f of x is 2, negative 5, then what is the domain of the function? So we want to know what the domains are. Okay. How do you find the domain? The domain is, so f of x is 2, 5, meaning that the graph starting from negative 2 and going to 5. Okay. So what did the graph do? The graph moved up once. And how many times did it move over? It moved over 3 times to the left. So if I'm looking at the domain, I don't really care if it moved up. I more care if it moved left. So if I'm moving left and my domain is negative 2, 5, and I move left 3 times, left is going in that direction, so that means the graph had to have moved over that way. So I'm going to add 3 to that. So if I move left 3 times, I'm going to go from negative 2 to now negative 5. Still moving left. So if I move left and I'm at 5, I'm now moving to 2. So all I simply did in this case, because I'm moving left, I kind of minus 3. Okay, we just minus 3. Okay. So again, domain. If this was the range, then we look up and down because we're looking at the graph. Okay, that's the y-axis. Y-axis moves up and down. It's the x-axis, it either moves left or right. Okay. Okay, sketch a function over the intervals that meet the following criteria. So we kind of talked a little bit about this previously. We kind of struggled with this as well, about relative maximum, absolute maximum. So I have a graph between negative 5 and 5. So my graph can't go past here, and it can't go past here. Okay. So relative minimum at negative 2. So relative minimum negative 2, my graph somehow has to go here. Has to go low here, okay? Then it says absolute minimum at 3, meaning that if this is 3, my graph has to go below the relative minimum, so it kind of has to go here, okay? Relative maximum at 5, so I'm going to look at maximum, looking at how high it has to go. Relative maximum mean I can start it probably here. Actually, relative maximum is 5, so let me actually erase this, meaning that it can't go, let's put it here. Let's put it here. And then absolute maximum is negative 5. So that means it has to be higher than this. So I'm going to put it up right here. And then I could do this a lot of ways. I can go like this. Right, I can go back here. So maybe I move the 5 over. Let's see, I'm gonna do that differently. So relative minimum is negative 2, so maybe I move it here. Absolute max minimum 3. So it has to be below that. Maybe I'll move it here. The relative maximum is 5. So maybe I move it, let's see. I can move it here maybe. And then absolute maximum has to be negative 5. So maybe I move it up here. Okay, so maybe I go something like this. I can just go like this. Okay, maybe I can do just like that. Okay, because that kind of covers it. Maybe I'll do this. Since this has to be a little... And again, this question can be done a lot of different ways. I just want to make sure that we're good with this one. Maybe I'll make this here. Maybe I'll make this a little lower. Maybe I'll do a little curve. I can start here. Maybe do a little curve. Then down like that. So again, that's what you could do as well, okay? Sketching should be easy, should be simple. All right, inverse again, we talked about it. Inverse, I'm not gonna spend more time on it. Turn this into y equals 4x plus 8. change the y to an x, change the x into a y, and solve for y. Okay? Determine algebraically, this is the even function. Again, in order to determine it's an even function, you're going to make everything negative x. You're going to change everything into negative x, okay? That's how you determine if it's a function. And again, just so quickly so we can solve this question, and Seth actually did a good job with this in class. Confirm it's an even function. I'm going to change it all over, so I'm going to make it h of negative x equals negative x to the third, parentheses, plus negative x squared plus x. And then what you'll realize is it's not even because they're not going to be equal to each other, okay? With graph and sketches, so example, how do we write this? So if this is my original equation, which is f of x, how do I write it? So I'm going to pick the points. I got a point here and I got a point here. What really happened? I just went up, 1, 2, 3. So I know g of x equals f of x plus 3 on the outside, because I just went up. Okay. Again, sketching the same graph, because it says plus 4, that means I went left 4 times. Okay. Questions? I hope not. Last question, we talked about factoring completely. Just again, make sure that you do the cube root of each one to get a. Cube of 8 is 2. Cube root of x to the third is x. And then the same thing again, this will be 2y. And then you use the formula from there. Okay. Again, any questions or concerns, please email me. Okay. Please study. Please get this done. You'll be fine. All right. Take care, guys. Good luck.